Let's introduce a simple but very powerful theorem called the work-energy theorem. Just an introduction. This is it. The net work done on an object is equal to the change in kinetic energy of the object. Very simple to write. Now, what does that mean? Let's use an example. Let's say that you are pushing a wooden crate along the floor at a constant speed. So let's draw all of the forces on this crate. You have the normal force, or the support force, of the surface holding up the crate, and you have the force of gravity. You have the force of your push, and you have the force of friction acting against your push. Now, we said that the speed of the crate is constant, so it might be 1 meter a second, and after some time it's still 1 meter a second, and after some more time it's still 1 meters per second. You are moving the crate, but you're not speeding it up because friction is acting against the force of your push. Now, what's the change in kinetic energy of the crate? Well, it's 0. Now, how do we know this? Well, kinetic energy is equal to 1/2 mv squared. And if our speed is always 1 meters per second, then there is no change in speed, and so there is no change in kinetic energy. That means that, surprisingly, you are doing no net work on the crate, even though you are moving the crate. Relatedly, the net force on the crate is 0. So we see that when we have no net force on an object, then you do no net work on the object, even though you might be pushing on the object, as is the case when you are pushing on the crate. You have to take into account friction when you are calculating net work. Here's another example. How much work would it take to accelerate a 1 kilogram model car from 0 to 10 meters per second? What about from 0 to 20 meters per second? Well, let's break this down into two parts. We're asking what the amount of work is from 0 to 10 meters a second first. So initially, the car is not moving, so it has no kinetic energy, 0 joules of kinetic energy, because its speed is 0 meters per second. And once it reaches 10 meters per second, it will have how much kinetic energy? Well, let's calculate that. Kinetic energy is 1/2 m times v squared, or 1/2 times 1 kilogram times 10 meters per second squared. We know that the mass is 1 kilogram and the speed is 10 meters per second, and we square that, and what do we get? Work equals the change in kinetic energy. So, the final kinetic energy of the car after it's reached 10 meters per second is 1/2 times 1 kilograms times 10 meters per second squared, minus the initial kinetic energy, which is 0. So the kinetic energy or the change in kinetic energy of the car is 50 joules. That's 100 times 1 divided by 2. So the work it requires to accelerate the car from 0 to 10 meters a second is 50 joules. Part 2. How much work does it take to go from 0 to 20 meters a second? Again, the initial kinetic energy is 0. And at its final speed of 20 meters per second, the car has this much kinetic energy. Again, the formula, 1/2 mv squared equals 1/2 times 1 kilogram times 20 meters per second squared, or 1/2 times 1 times 400 joules, or 200 joules. So the final kinetic energy of the car, when it's reached 20 meters per second, is 200 joules. So the change in kinetic energy is equal to 200 joules minus 0, and since the change in kinetic energy is equal to the work that it requires to accelerate the car from 0 to 20 meters per second is 200 joules of work. From 0 to 10 meters per second takes 50 joules of work. To go from 0 to 20 meters a second takes 200 joules of work. Let's compare two things: the change in the car's speed and the change in the amount of work it takes to get that final speed. The final speed of 20 meters a second is only twice the final speed of 10 meters a second. But it takes 4 times as much work to get the car from 10 meters a second, or to get the car to go from 0 to 10 meters a second, to get it to go from 0 to 20 meters a second. Here's a further complication. If the force on the car is constant, how much more distance is required to go from 0 to 20 meters a second as compared to 0 to 10 meters per second? The answer is 4 times the distance. 0 to 10 meters a second is 50 joules, and 0 to 20 meters per second is 200 joules. That's 4 times the work, so you get 4 times the distance. Doubling an object's speed then takes 4 times the work because kinetic energy equals 1/2 mv squared. This is the key point. That second power in the equation is where you get the 4 times factor. The second video you are about to watch will use this fact further.